Now we're ready to go a little more in depth into the properties of the mean. Here we have two brands of batteries, brand A and brand B. Each dot represents the battery life in minutes. Now if we find the means for these two types of batteries, what we find is that they're pretty much the same. And what the means would tell us is that, that they're getting about 101 minutes of battery life. What the mean isn't showing us is that this brand of data has data that has a much larger range. You might get a battery that lasts 75 minutes, you might get a battery that lasts 90 to 95 minutes, and you might get a battery that lasts up to 120 minutes. But this battery is a little more consistent. You're going to get between 95 and 115 minutes, which is much better than a range from 75 to 120. So if you were looking to purchase one brand of battery, you would want to go with brand A, because at least it's more consistent, and you know it's definitely going to get in this area of battery life, rather than this entire area of battery life where all the data is skewed. What this is known as is variability. Brand B is going to have more variability than brand A because the data varies. Here the data isn't varying as much. So in this case of the battery, the variability is bad. We don't want a brand that's going to have bad variability because it's inconsistent. So basically when you look at a dot plot, if it has more separated points, if it has a bigger range of points, then it has more variability. If it doesn't, it has less variability. But what about when you have a lot of data? We're going to want to use something called the deviation from the mean to show us the variability of our data. So I just rewrote our data set in number form, and what I basically did was I had each point of life and I found the deviation from the mean. So what is the deviation from the mean? The deviation from the mean is literally the mean, which is represented by this, x with a little squiggle line over it, minus our point, which I'm going to represent by x. So our mean for brand A is 101, and let's say our point was 83. So our deviation from the mean is 18, or our point is 18 less than the mean. So here, when it's ever to the left of the mean on our dot plot, it's going to be denoted by a negative sign. Whenever it's to the right of it, it's going to have a positive sign. But what we're not looking for is if it's positive or negative. That's irrelevant. What we're basically looking for is the numbers. So here we see that from the mean, the largest it's going to be bigger than is 18. But down here, our mean was 100.5. I did the same thing to find our deviations, and the deviations are much larger. 27.5, 23.5. And that's a much larger range, from 224 to 73 instead of 114 to 83. So what this deviation does is it proves that there's more variability here than there is here because there's a bigger range, and there are a lot more points that are much larger or much smaller than our mean. So what we found is that variability is important in certain cases, and that the way to find it is by using the deviation of the mean, which is finding the difference between the mean and a data point to find our deviation. Knowing this can help us tell something like a battery, such as which is a more reliable battery type. Hey, thanks for watching this Crash Course video. To watch the previous video in this series, click here. To watch the next video in this series, click there. If you want to request a video, make sure you put it in the comments below. And don't forget to subscribe and like this video.